Hey everybody, in this video we're going to be discussing multiple linear regression. Previously, we discussed just linear regression. We used only the size of a home to predict the price of a home. And while yes, this is fine, it isn't really accurate because there are ultimately many factors that would influence the price of a home, which is where features come in handy. Features are characteristics of a data point. So for example, this data point right here has multiple features, right? The size, the number of bedrooms, the number of floors, the age of the home, and this influences the price of this home. So the way we denote a feature is by using subscript. For example, x subscript j is equal to the jth feature. And like I said, features are characteristics of a data point. So this is a single data point, this whole row right here. And it gives you many details. So a feature is the column in this case. So our first feature would be the size of the home. x1 will denote that as. The second feature is the number of bedrooms. The third feature is the number of floors. And the fourth feature is the age. And the price is the output. So that's not a feature. Like I said, features are parts of the input. x1, x2, x3, and x4 are all characteristics of the input. They tell you more about the input. Okay, next, we'll denote n as the number of features. So in this case, we have 4 features. Pretty self-explanatory. Circling back, to denote a training point or a data point, we will use superscript. So x superscript I is equal to the features of the ith training example. And you have to include features because now for each data point, there are multiple features. So this entire row here that I circled, this entire row can be denoted as x superscript 2. This is a training example. And this training example stores the features. But when we just look at the input, we will actually exclude the output here. Okay? So this right here now, instead of circling the entire data point, now I'm going to be circling just the features. So the superscript will be denoting the features of the ith training example. And say we want to access a specific point, okay, like a specific number in this data table. Well, then we combine our rules of using or grabbing a feature and grabbing a training example. So it'll look something like this. So x subscript j superscript I will access the value of feature j in the ith training example. Okay, so for example, say we wanted the point x subscript 3 superscript 2. Well, the superscript 2 tells me that, hey, I want to access the second training example. So this row right here. And the subscript 3 tells me the feature. So we want this feature over here, the number of floors. So then we know that x subscript 3 superscript 2 is equal to 2. Pretty simple. Okay, let's move on. So now you might notice that I use an arrow right here. And if you've taken higher level math, you'll know that this arrow indicates a vector. And if you don't know what it is, that's perfectly fine. But a vector is like a list of numbers. You can kind of correspond it to an array in certain coding languages. So it has a list of numbers. So for example, the vector of the second row will store these numbers. So before, when we just had one feature, x superscript 2 would just store this number. But since we have multiple features, we're going to have to store each input in a vector. So each training example in a vector. So this vector will hold this row. So it will have 14, 1, 6, 3, 2, and 40. This is a vector, okay? So when we incorporate multiple features, we actually have to change our model just a little bit. You might recall that before we represented our linear regression model as something like this. However, this is when we just had one feature. Now we have multiple features, and for each feature, we have to do something with the feature to get an output. So before we just manipulated one feature, right? We'd manipulate this value because this is an x value, right? And we'd multiply it by a value of w and then add a value of b to get our f, right? Our output. But now we have multiple features and we have to manipulate each feature now. to get to our predicted output. So we have to expand our model just a little bit. Now we'll rewrite this as this. So hopefully you can see what I've done here. Before we just had one feature, now we have 4 features. All the x's denote a feature. And from the data table, we have 4 features here. So we must multiply each feature by a value of w. Remember, the w of value is a parameter, and these w's may vary for each feature. But the goal is to minimize the cost function, so we'll be manipulating each feature by some value w, and of course adding value b, which is a constant, to get our predicted output. And we can generalize this even further. Okay, so now I've generalized this. I would also like you to note that b is not a vector. What is a vector is w and x. W are the weights. So in vector format, it will look like this. You can see that it corresponds to this model above. And our inputs, or our x's, will also be in a vector. Okay? And if you notice, these values here are actually being multiplied with one another. You see, w1 is multiplied by x1, w2 is multiplied by x2, and so on. And because these two are in vector format, we can use what's called a dot product. So we can actually rewrite this model over here as a dot product. So f, and now no longer, w is not just one value, it's a vector. So we have to include that arrow above it. But b is not a vector, so we will not include the vector above it. X is a vector, so we will include an arrow above it to denote that it's a vector. And instead of, writing all these values like w1, x1 plus w2, x2, even if we generalize it, we don't need to do that. We can just use the dot product. And the dot product looks something like this. The vector w times the vector x, and of course we have to include the value b. And what this dot product does, where we're like multiplying the two vectors here, is it basically carries out this process. It'll multiply w1 by x1, w2 by x2, w3 by x3, and so on, all the way to wn and xn, okay? And this is called vectorization. We can implement this by using vectorization. So when we implement this in code, we can use actually a code statement like this. F is equal to np dot w, comma x plus b. And this is equivalent to this, what we just talked about. So when you want to use a dot product in code, in Python specifically, you can use this statement right here. And using a dot product is much faster than any other solution you might think of, like iteration or brute force, right? You might think, oh, I'll iterate through each value of w and each value of x and multiply the two together. Or I might brute force it. No, using this statement, the dot product statement, is actually faster because it performs w1, x1, all the way to w and xn simultaneously instead of one at a time. So let's update our gradient descent notation using the vector notation. Okay? So now our parameters, instead of just w and b, w is actually a vector. B is not. Okay? So that's a small change. And now our model. Before, we just had wx plus b. Now they are vectors. So we will use the dot product. Okay? That's the dot product. We can't forget about the cost function either. The cost function, which we want to minimize. And this before was j of w and b. Remember, w is now a vector. So we'll denote that with an arrow above it. And of course, we have to talk about gradient descent. So remember, we will repeat the following in gradient descent. You might notice I included a subscript j for each w. Don't worry, I'll get to that in a second. So we can expand this, as we've already discussed in previous videos, as the following. If this is unfamiliar to you, please visit the previous videos. Okay, so let's talk about the wj. When we make these changes, we're going to be simultaneously updating wj for each j from 1 through n. Okay, we are going to be simultaneously updating wj, j is equal to 1, and of course b. Well, remember, for each feature we had a w, a weight to multiply the feature by. So we have to use gradient descent to change each value or each weight iteratively. Remember that. So each iteration we update each w and b. Okay, thank you for watching.